All right, so we'll do some more examples of solving inequalities. So again, it's the same process we use to solve equations. So the first thing I'm going to do is simplify my expressions on each side. All right, so on the left side, we got two terms. I'm going to distribute the factor of -1 to each of these terms. So when I do that, I'll have the 2. -1 times x is -x, and then I'll get another -1 times 5 is -5. So we'll combine like terms, and we get -x. 2 and -5 is -3. So that's less than. On the right side, we have two terms, and we'll be distributing a 2 to these two terms. So we'll get two more terms. We'll get a 6x. 2 times 3x is 6x. 2 times 4 is +8. And then we'll have the +10. And if we combine like terms here, we get 6x plus 18. So now we'll start solving. I want to isolate the variable term on one side. And again, it doesn't matter which side you do this. I like to avoid negative term values or terms. So what I'll do is I'm going to zero out the -x on the left. I'm going to attach x or add x to both sides. That's going to give me a 7x term on the right. So if I isolate my x terms on the right side, that means I need to get rid of the 18. So I'll zero the 18 out and on both sides, and I get a -21. So finally, to get x by itself, we need to cancel that 7. And this time, it's a positive factor, so we do not have to change the inequality. -3 is less than x. Now, what I like to do is rewrite this as x, and then we need to, if we write the x first and read it, x is greater than, we need to make sure the symbol follows or is opening up to the x to get the correct meaning. So if -3 is less than x, that means that x is greater than -3. So if -3 is less than a number, then the number has to be greater than -3. So here's how I like to have my answer. X is greater than -3. If we graph this, would be an open circle at -3, and greater than would be pointing to the right. So that would be the graph. And then our interval notation, -3 to infinity with parentheses. So this would be the graph in my interval notation for that. So again, we don't really change how we solve. We still have the same steps when we solve. It's just that when we're done, we want to interpret the solution correctly. Even if we have an inequality with fractions, we can clear fractions and to help us out, right, with our expressions. So with this one, probably multiply both sides by a common denominator or a factor that will cancel every denominator. So a 10 will cancel every denominator. It'll cancel a 10, a 5, and a 2. So we'll multiply everything by 10. Again, when we do this, when we multiply with fractions, we want to take advantage of the canceling, so that here we multiply by 10. The 10 in the denominator will cancel with the 10 we're multiplying with, and we're going to be left with 7x. So this will have a 7x when we're left. When we multiply the 10 times the negative 1/5, the 5 will cancel with the 10, but it leaves the factor of 2. So this time, our term then would have to be negative 1 times 2, which is negative 2. So that's greater than or equal to. Now we'll distribute the 10 here to x over 2 again. This time the 2 in the denominator will cancel with the 10, and it leaves a factor of 5. So the term that we get here would be 5x. And we still need to distribute the 10 to the 3. Nothing cancels, so I just multiply. This would be plus 30. So clearing fractions is a good way to simplify. Now we'll start isolating the variable term. On one side. So in this case, maybe we'll zero out the 5x term on the right. That'll give us, on the left side, that'll give us 2x. And if we're going to isolate the x term on the left side, then we need to zero out the negative 2. We'll add or attach 2 to both sides. So we get 32 on the right side. And then isolate the variable factor as our last step. Here, I'm going to cancel that factor of 2. And again, we're dividing by a positive number, attaching a positive factor, so we do not. X then would be greater than or equal to, and we could cancel this with a 16. And we do not switch the sign because we're dividing by a positive number, attaching a positive factor. So if we graph this, we just want 16. That's our boundary with the solid circle again. Since it's greater than, it's to the right again. Okay, so we'll try some different examples and then an application in the next lecture.